Good morning, everyone. My name is Nguyen, and I'm excited to talk to you about our ground station observation network and how we use Amazon ground stations to deliver low latency direct broadcast data products. I want to acknowledge the NASA ESTO Advanced Information System Technology Program for funding this work and our Langley SATCOR team for performing this work as well. We know that we have latencies that can occur at different stages. This can occur at the data acquisition at the ground station, to the data transfer to the data center. It can also occur at the processing and distribution centers. This latency can be in the order of 1.5 to 3+ hours. On the top of the slide shows a traditional method to acquire the stored mission data that was recorded on the spacecraft. The bottom half shows how we would get direct broadcast data in a cloud environment using ground station as a service provider. Here we see that the ground station, the storage, and the computing instance and the distributions are all co-located within the Amazon cloud network. This enables us to generate products and deliver them at a much lower latency, typically under 25 minutes and as low as 12 minutes for some products. So how does ground station as a service work? Amazon provides us with access to the global network of ground stations, all of which are located within the Amazon data center. We onboard the satellites that we're interested in, like NPP, JPSS, and Aqua. Once onboarded, we can schedule downlinks of the direct broadcast data. When the satellite approaches the ground station, the VP's instance launches and receives the data and streams the data directly to the S3 bucket, where it's then processed and distributed on the cloud. The instance is shut down upon completion, and you only pay for the time that is used. This is a data-driven service. Amazon currently has 10 ground stations that is operational, and they continue to add more worldwide. This map shows where we successfully received VIIRS data from 8 of those 10 ground stations using GSON. We have yet to onboard over Punta Arenas and Sydney antennas. The antennas are capable of receiving X and S-band frequency. K-band is a possibility in their roadmap. This is a pay-as-you-go service for antenna usage, and it costs $3 per minute under the reserve contract pricing and $10 for on-demand without a contract. So an overpass about 13 minutes can cost about $39 or $130 depending on the plan. We can expect the price to be negotiable with a higher data volume usage. Here we see a high-level diagram showing the 4 major components of GSON. We have the commercial Amazon ground station to capture the direct broadcast data. We have the GSON planner and scheduling service, which allows us and users or applications to interact with the API service to request the direct broadcast data. It can also monitor events like fires or flooding for triggering. Next, we have the Amazon Cloud and the CloudWatch services. And finally, we have the GSON processing framework, which Thad Chi would be talking more about in the next talk. This is where the workflows for data ingest, different processing levels, and the data distributions are performed. This is a data-driven architect where data requests and arrival of data drives the processing flow. With the GSON Service API, a user makes a request with criteria requirements, and the planner schedules the appropriate ground stations, selects the time, and creates a schedule. When the satellite passes by, the VPN instance spins up to receive the raw data. This auto triggers the processing and delivers the data to a landing zone. Then a message is dispatched to the user for data pickup. This is a visual illustration of how the planner determines which overpass is scheduled for a single point lat long location based on user requirements such as viewing zenith constraints, date ranges, or pass criteria. Description can be for one day or multiple days, and the planner and the scheduling service would manage that request. This is a similar illustration, but here we use a bounding box over West Coast, California. In this request, we want to conserve costs, so we want only the best overpass between JPSS and MENPP for both the daytime and the nighttime. We want the best overpass between the two satellites because of the similar local time. Here we see MPP overpass being selected as the best day time pass, and JSPP for the nighttime pass, which are both highlighted in cyan. Again, a subscription service can be made to order multiple days, and the planner and the scheduling service will manage the requests. So here are some of the things that we can use GSON for. We can use it as a satellite ground station node to support current and future AIST new observing strategy demonstration. We can use it ad hoc to respond to events or natural disaster, particularly fires or flooding. It can be used routinely to monitor or provide coverage over a ground site without the need to own or operate a direct readout station. It can be used to provide low latency LEO data to support field campaigns, especially in the high latitudes where geo data is not useful. We can use it to provide subscription services, to provide direct broadcast data on a need basis. This was our first use case scenario that we demonstrated. We were funded by NASA AIST program to implement a prototype new observing strategy testbed node to support the flood demonstration. We supported the testbed historical flood demonstration that we conducted in the spring of 2021, and also a live demonstration during the fall of 2021 as well. The node received, process, and deliver Veer's flood products to the flood model in under 25 minutes. The GSON node can be triggered by stream gauges when it detects high water, or by the forecast model prediction of areas over flooding, potential flooding. And also a user application also enroll in a subscription service via the API. Here's another demonstration that we conducted. This one is with Kyle Hilburn from the Warspire group. This is a proof of concept demonstration to deliver low latency Veer's active fire products to the Warspire forecast in under 12 minutes. They provide us with a bounding box over California to capture the Veer's data. The lower left image shows a typical overpass selection. The Veer's active fire helps initialize the fire perimeter of the KMP fire that was going on at the time. And it grew from 51,000 acres to 85,000 acres in a span of 8 days. The worst fire produced a 48-hour forecast, and they ran the low latency data that we provided at the 9 and the 21Z, which is the same as their operational forecast at 12 and 0 respectively. They found that the results were quantitatively similar, and that they're able to simulate the low latency data successfully without much effort, but with a much quicker turnaround. They were able to provide the same forecast 3 hours sooner. So how much does this cost to use Amazon Ground Station and process the direct broadcast data on AWS? Um, our computing and storage cost during our demonstration was roughly about $300 to $500 range per month. This was considered a light usage. With more routine, everyday usage, we can expect it to be around 1 to 2K range per month, depending on the processing requirement of the level 1, level 2, and level 3 products. The majority of the cost would be for the antenna usage at $3 per minute on the reserve plan. Let's say we were to provide continual daily coverage over a ground station from one satellite with roughly 2 overpasses per day, would cost around 26K per year. This cost can possibly be reduced with some negotiation with Amazon. Currently, there's 10 operational ground stations, and Amazon plans to add more ground stations in the future. Right now, we can reserve contacts out to 5 days and a minimum of 10 to 30 minutes before the satellite passes by the ground stations. So over the past 2 years, we only seen one outage due to a bug in the software upgrade. So it's been pretty reliable. Now onto the summary. We deployed GSON system on Amazon. We built a planner and scheduling service along with the scalable processing framework to enable the capturing, processing, and delivering of low latency data products. We can deliver flood products in under 25 minutes and fires in 12 minutes. GSON processing framework customizable and scalable. It's well suited for ad hoc use to respond to events or natural disasters such as fire or flooding. We have a meeting with Zoro Orbital next week to explore use of Microsoft ground stations and expand it beyond Amazon. With Amazon Zero KSAT Lite, we will have the ability to provide more global coverage. We have future collaboration that we're working on, working with people to use GSON. Hopefully, we can get Lance to adopt our technology and capabilities. We plan to work with the Solar Project. DoD is interested in our technology and want to run our code through Platform 1 hardening process and deploy it for functional use. We will be working with Applied Science Program to provide a subscription service to support the wildfire community this fire season. We are actively looking for collaborators, and if you're interested, please don't hesitate to contact me. And that's all I have. If you have any questions now, my colleague Thad Chi will try to answer them. Thank you for your time.